Beneath the infinite silence of the void, light drifts across time like whispers from forgotten ages. Each photon carries a memory, born in a furnace older than Earth, crossing a gulf of billions of years to finally fall upon a waiting mirror. In this endless night, James Webb stands as humanity's great lantern, its golden petals unfurled like the eye of a god, gazing deeper into the past than any being has dared. It does not simply see stars. It gazes into the childhood of creation itself. At first, the view seemed familiar. Galaxies strung like jeweled threads upon the cosmic web, their light stretched and thinned by the passage of time. But then, something unexpected appeared. Shapes too ordered, brightness too intense, structures too ancient for their place in the timeline of the cosmos. Galaxies that should not exist so early, blazing with impossible maturity, as if the universe had written chapters out of sequence. The laws of nature bent like shadows under an alien sun. Every equation of formation, every careful model of cosmic dawn quivered beneath the weight of this revelation. For if the galaxies are real, if their stars truly lived and died in the universe's first moments, then the story of creation is not the one physics has, told in the hush between discovery and understanding. One truth presses down with the gravity of entire worlds. Our most powerful eye has glimpsed something that does not fit, something that challenges the very foundations of cosmology. The telescope was built to confirm, to refine, to illuminate. Instead, it has unsettled. And now, as humanity peers through this cosmic window, physics itself seems to tremble, as though reality is reminding us that it is not bound by the limits of our imagination. In the long arc of human curiosity, there has always been the yearning to see further, to peel back the layers of darkness and find the first sparks of creation. For centuries, the night sky was an ocean of mystery, its faint lights charted by naked eyes and fragile instruments. Then came the age of Hubble. Suspended above the atmosphere, Hubble lifted the haze of Earth's distortions and revealed a universe far richer than imagined. Its deep fields showed galaxies beyond counting, stretched across billions of light years. Yet even as its images astounded the world, they also betrayed a limit. At the furthest reaches, the light grew faint, smeared, and broken, as though the story of the cosmos could only be half freed through a cracked and dusty lens. Scientists knew that what lay beyond those limits was not emptiness, but history itself. The earliest galaxies, the first stars, the dawn of cosmic order. But such relics do not shine in visible light. Their glow, stretched by expansion, slips into the infrared wavelengths, invisible to the human eye and to Hubble's aging gaze. To glimpse them required something new, something extraordinary. Thus was born the vision of the James Webb Space Telescope, not a successor in scale alone, but in purpose. A telescope not built merely to see, but to listen to the whispers of ancient fire. Its mirrors, plated with gold, would drink in the faintest warmth. Light stretched across nearly 14 billion years of time. Its instruments, tuned to the infrared, would open windows where before there had been only blindness. It was a dream many thought too fragile to succeed. Webb was a machine of impossible complexity, a puzzle of 344 single points of failure. Folded like origami within the nose of a rocket, it carried with it decades of work, billions of dollars, and the collective hope of a generation of scientists. Launched into the silence of December 2021, it sailed not into low orbit, but to the distant Lagrange point, 1,000,000 miles from Earth, where gravitational balance could cradle its delicate sunshield and keep it cool enough to hear the faintest echoes of the cosmos. When at last it unfolded, Mirror by mirror, layer by layer, the world held its breath. A single jammed hinge, a misfired bolt, a tear in the shield would have silenced it forever. But the unfolding was flawless, a ballet of precision in the vacuum of space. The golden eye opened, steady and unblinking, to a sky older than memory. The expectations were clear, if cautious. Webb was to refine Hubble's triumphs, to map early galaxies more clearly, to test and perhaps gently adjust the prevailing standard model of cosmology, the framework that had guided astronomy for decades. No unexpected revolutions. Webb was to be a confirmation, a sharpening of the lens, a servant of consensus science, and then came the first deep fields. Thousands of galaxies filled a speck of sky no larger than a grain of sand held at arm's length. Yet their light had traveled from epochs unimaginably remote, when the universe was only a few 100 million years old. What Webb revealed was breathtaking, not only in beauty, but in contradiction. There, at the edge of time, galaxies shone with impossible brightness. Some held structures that should not have had time to form, spirals and disks where chaos should still have ruled. Star clusters, heavy with elements that required generations of stellar birth and death to create. They were too massive, too mature, too soon. By every model of cosmic evolution, such galaxies should have taken billions of years to grow. Yet Webb saw them alive and radiant. Scarcely 300 million years after the Big Bang, the discovery struck like a fracture through the foundation of cosmology. The standard model had explained so much: the formation of stars, the growth of structure, the delicate balance of dark matter and energy. But these galaxies, glowing defiantly from the first dawn, suggested that the universe had moved faster, grown bolder, written its early chapters in a script no physicist had predicted. It was as though a history book had been opened, and within its earliest pages one found the signature of civilizations already ancient, written in a language not yet learned. Webb had not merely refined the story of the cosmos, it had unsettled it. The shock spread quietly at first, not with thunder but with silence. Scientists who had spent their careers refining models of galaxy formation stared at the early Webb data and felt a tremor of disbelief. For decades, the framework had seemed solid. After the Big Bang, the cosmos expanded, cooled, and filled with dark matter scaffolding. Hydrogen and helium collected into clumps, igniting the first stars. These earliest suns, massive and short-lived, lived only long enough to enrich their surroundings with heavier elements, laying the groundwork for galaxies to grow. According to this sequence, the universe in its first few 100 million years should have been a wilderness of small, chaotic structures flickering with primitive light. Yet Webb revealed vast systems, already orderly, already mature, burning with the light of countless stars. In laboratories and offices across the world, teams began to check and recheck. Was the redshift wrong? Could calibration errors have stretched the data beyond its true value? Were the galaxies nearer, their light merely masquerading as ancient by some quirk of dust or lensing? But spectroscopic confirmation, the gold standard of cosmic measurement, upheld the impossible distances. These galaxies were not they were real, and they were older than the models allowed. The moment recalled past upheavals in science, the discovery of quasars too luminous to comprehend, or pulsars mistaken for signals from alien civilizations. In each case, the universe had written riddles that demanded new language to be read. Webb was writing another. What made the revelation more profound was the scale. Not one or two anomalies, but a growing catalogue of galaxies, each defying expectations. Their sheer numbers implied that the early universe was not an exception, but a rule rewritten. Where cosmology had predicted scarcity, Webb showed abundance. Where the story had anticipated gradual unfolding, it showed sudden brilliance. The earliest dawn of galaxies appeared crowded, as though creation itself had rushed forward in an impatient surge. For many, the philosophical weight was as unsettling as the science. If galaxies could bloom so quickly, then the physics of star formation, the dynamics of dark matter, or even the behavior of gravity itself might need reconsideration. Each possibility carried consequences that rippled outward, touching the very architecture of cosmology. It was not only a question of how galaxies formed, but whether the timeline of the universe itself had been misunderstood. The unveiling of these first deep fields marked more than an observational triumph. It was a reminder that the cosmos, no matter how deeply measured, remained stranger than human theory could capture. Webb's golden mirrors had not only seen further, they had uncovered a riddle embedded in the fabric of time. And as the images spread across the world, scientists realized they were standing at the threshold of a new narrative, one where the oldest light in the universe might demand the youngest of theories to explain it. At first, the images arrived as numbers, streams of raw data arranged in columns plotted on screens, transformed into the luminous shapes that would soon circle the globe. To the untrained eye, they were beautiful, dazzling portraits of cosmic history. To the astronomers who first examined them, they were unsettling. Some of the galaxies gleamed too brightly, their spectra whispering distances that seemed beyond reason. For a moment, the natural instinct was doubt. Surely this was a flaw in calibration, an echo of software misalignment, or a trick of cosmic dust bending the light. Telescopes, after all, are not flawless prophets. They are instruments bound by machinery and mathematics, and both are vulnerable to error. Teams across continents moved quickly, running verification checks, scrutinizing the processing algorithms, comparing independent reductions of the same raw light. In the quiet hours of the night, astronomers stared at their monitors, hoping to find the misplaced decimal, the overlooked correction, the ghost in the machinery that might explain away the impossible. Yet the ghosts never appeared. Each round of verification confirmed the galaxy's reality, their redshifts, locked in the fingerprints of hydrogen and oxygen, announced with unwavering clarity that they were indeed ancient. Their light born when the universe was still in its infancy. The reactions within the scientific community echoed earlier upheavals in human understanding. When Edwin Hubble revealed that the universe was expanding, even Einstein resisted, clinging for a time to the vision of a static cosmos. When Jocelyn Bell first detected the rhythmic pulses of radio waves that would later be called pulsars, the signal was so regular that some jokingly named it LGM, Little Green May at the edge of discovery. Wonder often walks beside doubt, and the line between revelation and illusion grows perilously thin. Webb's galaxies now stood on that knife's edge, demanding the humility of caution and the courage of imagination. Beyond the walls of laboratories, the media seized on the revelations with a frenzy of wonder and alarm. Headlines declared that Webb had broken cosmology, that the Big Bang Theory itself was in jeopardy. Yet among scientists, the tone was quieter, more measured. They knew the danger of premature proclamation. Theories are not shattered overnight, but reshaped through years of careful evidence. Still, the disquiet could not be hidden entirely. The sheer scale of the anomalies suggested more than a minor correction. They hinted at the possibility that the foundations of galaxy formation, dark matter clustering, or even cosmic expansion might need rewriting. Behind every discussion, behind every cautious statement, lay a deeper emotional tension. To glimpse something that does not belong to known physics is to stand at a precipice. The exhilaration of discovery is matched by the fear of delusion. A new universe beckons, but so too does the possibility of error, of years spent chasing a mirage born of faulty assumptions. For those who dedicate their lives to the cosmos, the stakes are not merely academic. They are personal, philosophical, even existential. To be wrong is to remain bound by the familiar. To be right is to admit that everything once held as certain may have been only a fragile scaffolding, now trembling beneath the weight of a truth too vast to ignore, and so the community held its breath. Webb had seen something extraordinary, but whether it was a mirror showing flaws in the human story, or a window opening onto new laws of nature, was not yet clear. In the stillness between skepticism and acceptance, science entered a moment of quiet awe, a recognition that the universe had once again placed before humanity a riddle written in light, daring us to decide whether to defend our models or let them be remade by the cosmos itself. In the weeks that followed, the first whispers of astonishment hardened into a structured debate. Workshops and conferences filled with uneasy conversations, where seasoned cosmologists found themselves repeating a phrase rarely spoken aloud. What if we are wrong? Theories that had stood for decades were placed on the table like fragile glass, examined under the weight of new data. Some argued that the anomalies were simply a matter of underestimated star formation efficiency, or of exotic early stars that burned hotter and faster than expected. Others warned against forcing nature to fit pre-existing models, reminding their colleagues that sometimes the universe refuses to bend to the convenience of human equations. The tension was not only intellectual but emotional, a quiet recognition that careers, reputations, and entire fields of research were suddenly under review by the verdict of Webb's golden mirrors. For many, the strangeness carried echoes of earlier moments when observation and theory had collided with violent dissonance. The first detection of cosmic acceleration in the 1990s, when distant supernova suggested the universe was not slowing but speeding apart, had seemed absurd at first. Yet it gave birth to the idea of dark energy, now accepted as a dominant force in the cosmos. The earliest mapping of the cosmic microwave background had revealed structure too intricate to be explained by ordinary matter, forcing acceptance of dark matter's invisible hand. History had shown, again and again, that resistance to the unexpected was temporary. While the evidence carved its place in science with quiet persistence, Webb's revelations now seemed poised to follow this tradition. The initial disbelief, the reluctant acceptance, and eventually the rewriting of textbooks, and yet the fear of illusion lingered. Astronomers are trained to be skeptics, to trust their instruments but never blindly. Could gravitational lensing have magnified distant galaxies into false giants? Could subtle contamination from foreground light be masquerading as ancient brilliance? To rule out these possibilities, independent teams rushed to obtain spectroscopic confirmation. Using Webb's own spectrographs, they measured the elemental fingerprints encoded in the light, decoding the true distances with precision. Each measurement came back the same. These galaxies were real, their age anchored in the redshift of the cosmos itself. The doubt began to dissolve, but with its absence came something heavier, the burden of explanation. The philosophical weight pressed in from all sides. If galaxies could exist so early, then the laws governing structure formation might not be universal constants, but parameters shaped by deeper rules not yet uncovered. Perhaps dark matter, long treated as a silent scaffolding, was more dynamic than believed. Perhaps gravity itself, so confidently described by Einstein's equations, revealed a subtle weakness when tested against the earliest ages of the universe. Each hypothesis carried profound consequences, not just for astrophysics, but for the nature of reality. The boundaries between science and philosophy blurred, as the question shifted from how do galaxies form to what is the true architecture of the cosmos. The community found itself in a state of suspended wonder, caught between the familiar comfort of models and the thrilling terror of revolution. Outside the walls of academia, the public imagination leaped ahead, embracing headlines of broken physics and cosmic upheaval. But within the circles of those who lived by the rigor of data, there was something quieter, almost reverent. They knew they were standing at the threshold of a transformation, but transformations are not declared overnight. They unfold slowly, like the universe itself, revealing their meaning only in time. And so they waited, not in silence, but in careful observation, ready to follow the light wherever it would lead. The first reaction to Webb's revelations had been disbelief. But disbelief is not enough in science. It must be tested, pried open, and either dismantled or confirmed. And so, across the globe, teams of astronomers began the painstaking process of re-examining every line of data, every calibration step, every shadow that could have slipped into the pipeline. Computers hummed with fresh reductions, codes were rewritten, and datasets were dissected in search of some hidden flaw that might explain away the galaxies that should not exist. For weeks, suspicion hung heavy, like fog over the field of discovery, delaying the moment when the extraordinary could finally be accepted as real. One by one, the instruments spoke again. Webb's near, infrareds, designed to read the elemental signatures imprinted in ancient starlight, delivered its verdict with precision. The faint smears of light, stretched across billions of years, bore the unmistakable fingerprints of hydrogen and oxygen, confirming their unimaginable distances. The mid-infrared imager, tuned to wavelengths invisible to human sight, traced the glow of dust warmed by the fires of early stars, sealing the conclusion that these were not tricks of lensing or foreground contamination, but galaxies truly born in the dawn of time. Cross-checks between instruments, carried out with a rigor honed by decades of skepticism, converged on the same truth. History offered an uncanny mirror. When Galileo first turned his telescope skyward, his drawings of lunar mountains and the moons of Jupiter were met with suspicion. To many, they were distortions of glass, imperfections of an untrusted tool. The leap from naked-eye astronomy to telescopic revelation had seemed too great, too sudden, too destabilizing. Now, for centuries later, Webb found itself in the same position, accused, doubted, and questioned, not because it failed, but because it revealed more than the human mind was prepared to hold. Yet the evidence was relentless. With each spectroscopic confirmation, skepticism faltered, and a heavier realization took its place. These galaxies were real, and they were older in form and structure than any cosmological model had permitted. This was no mirage of mathematics, no fleeting error of optics. It was a window into a universe stranger than the one written in textbooks. The dread that settled over the scientific community was not born of error, but of truth. If galaxies could assemble so quickly after the Big Bang, then the engines of cosmic creation must have been far more efficient, or far more exotic than previously believed. Perhaps clouds of pristine hydrogen collapsed with a swiftness unseen in later eras, igniting stars in dense clusters that defied the slow march of theory. Perhaps dark matter, that invisible scaffold, behaved differently in those early moments, pulling matter together with a force unaccounted for in simulations. Or perhaps the very fabric of cosmic expansion held a secret, whispering of physics not yet grasped. The question became larger than galaxies. It touched the very architecture of cosmology itself. For if the timeline of structure was broken, then what else might crumble under Webb's gaze? Was dark energy truly the silent master of expansion? Was dark matter truly as passive and cold as assumed? Or were both placeholders, convenient shadows cast over phenomena that had yet to reveal their true names? The early investigations ended not with clarity, but with unease. The universe had yielded answers, but each answer opened into deeper questions, vast and unsettling. Scientists had not uncovered a mistake. They had uncovered a mystery, one that would force the rewriting of the cosmic story itself. And in the silence of that realization, the greatest telescope ever built had done something profound. It had not only seen further back in time than any instrument before it, it had shown humanity that the universe it thought it knew was only the beginning of the tale. The investigations deepened, not only in the laboratories and observatories, but in the quiet solitude of offices where researchers stared at data late into the night. What began as a question of instrumentation soon became a confrontation with theory itself. For when every layer of Webb's machinery was scrutinized, when every correction was tested and retested, the galaxies remained fixed beacons from a time when the universe should have been too young to bear them. The line between illusion and reality had been crossed, and the path led into a territory where the foundations of cosmology trembled. Spectroscopic redshifts became the decisive proof. These measurements, extracted from the delicate spreading of starlight into rainbows, are the clocks of the cosmos. Each line, each absorption feature, testified to the immense distance and ancient origin of the galaxies. And they did not lie. Their redshifts placed them within a few 100 million years after the Big Bang, an era once thought too raw, too chaotic for such luminous structures to exist. The light had traveled for over 13 billion years to reach Webb's golden mirrors, and its story was now etched into the records of science. Teams cross-verified results with ground-based observatories, though Earth's atmosphere was far less forgiving than Webb's vantage in space. Yet even the faint confirmations from telescopes in Chile and Hawaii echoed the same refrain. The galaxies were real, and they were impossibly old. Doubt began to erode, replaced by the sobering recognition that the standard narrative of cosmic evolution no longer matched the evidence. It was as though an ancient manuscript of the universe had been torn, and entire chapters, once believed to be blank, were suddenly filled with ink. The psychological weight of this realization grew heavy. To question data is a natural instinct in science. To question the laws of formation and time is something far more daunting. Theories that had stood for decades, fortified by observation and mathematics, were no longer secure. The cosmic timeline from primordial plasma to the first flickers of starlight seemed compressed, accelerated, almost impatient. Stars and galaxies had leaped into being with a speed that mocked the careful pacing outlined in textbooks. For the scientists at the forefront, the discovery carried both wonder and dread. Wonder, because the universe had revealed its secrets in dazzling clarity. Dread, because those secrets implied that their understanding of the cosmos was incomplete in ways they could not yet define. The investigations, once aimed at finding an error, had instead forced the admission that no error existed. Webb's eye had shown the truth, and the truth demanded a rewriting of cosmic history. The chapter closed not with resolution, but with an opening wound, the realization that the early universe was far richer, far stranger, and far less predictable than anyone had dared to believe. Humanity had asked to see the first galaxies, and the universe had answered. But in doing so, it had also whispered a deeper question. If the beginning is misunderstood, what else in the story of the cosmos has been read incorrectly? The silence of the early universe was never truly empty. Within its first breaths, matter gathered, light scattered, and the seeds of galaxies were sown in darkness. Yet the James Webb Space Telescope revealed a truth far stranger than the carefully drawn theories of cosmology had foretold. For in its gaze, galaxies appeared not as fledgling structures still learning to shine, but as fully formed giants brimming with stars already old by cosmic standards. Their light carried the spectral fingerprints of elements heavier than hydrogen and helium-carbon, oxygen. Even traces of iron forged in the hearts of stars that must have lived and died before these galaxies came into view. The universe, only a few 100 million years old, bore the signs of generations already past. It was as though the cosmos had lived lifetimes in the span of moments, accelerating its story to a pace the equations could not keep. Chemical signatures spoke of furious cycles of creation and destruction, supernova igniting and collapsing in rapid succession, scattering the heavy atoms that would later build planets, oceans, and life. But here, in this distant epoch, they stood as paradoxes, relics of a universe too young to have known such abundance. And deeper still, Webb uncovered the blazing beacons of quasars, supermassive black holes accreting matter with unimaginable violence. Their light pierced the fog of cosmic dawn, luminous enough to outshine entire galaxies. According to every model of growth, such titanic structures should have required billions of years to form. Yet here they were, crouched within the first billion years of existence, burning with a brightness that mocked the slow arithmetic of accretion. Their presence suggested shortcuts hidden in the laws of gravity, or perhaps an origin story that had not yet been written. Then came the most unsettling of shapes, the ordered spirals, disks of stars and gas, symmetrical and serene, turning with quiet precision. But in this early era, chaos should have reigned. Galaxies were expected to be clumps and shards, colliding and merging in violent displays. Instead, Webb found elegance where only turbulence was predicted. Perfect spirals coiled across the darkness, as if the universe had skipped its adolescence and leaped directly into maturity. Each of these discoveries was more than an isolated anomaly. Together, they painted a picture of a cosmos racing ahead of schedule, as though time itself had been compressed. The scaffolding of the standard cosmological model groaned under the weight of these revelations. The equations describing dark matter, the cooling of gas, the birth of the first stars all seemed to slow, too hesitant compared to the reality written in ancient light. Scientists began to whisper of collapse, not of stars, but of certainty. For if the universe could produce heavy elements in an eye's blink, forge black holes larger than imagination in its infancy, and assemble galaxies into graceful spirals long before they should exist, then the very foundations of structure formation demanded reimagining. The cosmos was no longer a patient architect, but a restless sculptor, carving complexity at a speed that defied comprehension. And beneath the awe lingered a quiet unease. Perhaps it was not only the models of galaxy formation that faltered, but the deeper assumptions about space, time, and matter themselves. Webb had not merely uncovered anomalies. It had unveiled a universe with a hidden urgency, a cosmos that seemed unwilling to wait for the comfort of human theories to catch up. The story of creation was being rewritten in real time, and with every spectrum, every faint glimmer of ancient starlight, the mystery only grew. The more the data poured in, the more the unease grew. Webb's detectors, honed to perfection, revealed layer upon layer of contradiction. Astronomers had once imagined the first stars, the so-called population 3 stars, as immense furnaces, born purely of hydrogen and helium, living briefly and dying explosively, leaving behind only the faintest traces of their existence. Yet the galaxy's web unveiled bore signs that these ancient stars had already come and gone, replaced by second and even third generations. The fingerprints of carbon, nitrogen, and oxygen in the spectra of early galaxies told of a universe that had already been enriched. It was as though the first chapter of the story had been skipped entirely, leaving only echoes of a prologue that should have stretched longer across cosmic time. Each revelation seemed to compress the history of creation into an ever tighter frame. The birth of stars, the forging of heavy elements, the assembly of galaxies, all processes thought to unfold gradually over billions of years, appeared instead to have occurred with startling efficiency. Some models had predicted a universe reluctant to mature, where stars flickered into being hesitantly, galaxies stumbled through collisions, and black holes grew patiently. But Webb revealed a cosmos that seemed to be in a rush, an orchestra that began at full crescendo, skipping its overture entirely. The discovery of quasars only deepened the enigma. Supermassive black holes blazing so early defied the arithmetic of cosmic time. To grow such giants in less than 1 billion years required either seeds far larger than any known stellar collapse could provide, or mechanisms of growth that bypassed the normal pace of accretion. Some speculated that entire clouds of primordial gas might have collapsed directly into black holes, shortcuts written into the physics of the early universe. Others wondered if dark matter itself, silent and unseen, had played a role in sculpting these titans. Yet no explanation sat comfortably. The evidence suggested not a single anomaly, but a pattern, a consistent narrative of premature cosmic maturity. Then came the ordered disk galaxies, perhaps the most visually unsettling of all. Their spirals wound with symmetry, their arms stretched like brushstrokes across the black canvas of the early sky. By every expectation, such structures should have required billions of years of gravitational settling, the slow dance of matter coalescing from chaos into order. Instead, Webb showed them already complete, like sculptures finished before the marble had even cooled. It was as though the universe possessed a hidden efficiency, a preference for harmony when theory insisted on disorder. Each breakthrough observation was a crack in the edifice of cosmology, but together they formed a chasm. The timeline of the universe, once carefully charted from simplicity to complexity, had begun to fold in on itself. If galaxies could form this quickly, if stars could cycle through generations in a cosmic heartbeat, then the scaffolding of the standard model stood on unsteady ground. The equations that had guided decades of research seemed to be whispering an incomplete truth, a truth that Webb's golden mirrors had now exposed. For astronomers and physicists, the implications stretched beyond galaxies and black holes. If the early universe matured so quickly, what did that mean for the role of dark matter in structure formation? What did it mean for the delicate balance between gravity, radiation, and expansion? Even the very age of the cosmos seemed, for a moment, to blur at its edges. Webb's revelations did not simply challenge the details of cosmology. They hinted at flaws in the framework itself, in the stillness of observatories and conference halls. A quiet recognition took root. This was no longer a matter of adjusting parameters or fine-tuning equations. The discoveries spoke to something deeper, perhaps something missing from the very foundation of physical law. A universe that grew up too fast was more than a puzzle. It was an invitation to rethink everything. And as scientists stared into the faint light of galaxies older than imagination, they could not escape the sense that the cosmos was telling them a story they had only just begun to understand. The revelations did not slow. With every new image released, the James Webb Space Telescope seemed to deepen the enigma, turning what had once been anomalies into a growing chorus of contradictions. Among the most startling implications were the dark halos of matter, the invisible scaffolding the theory declared essential for galaxy formation. These halos, vast cocoons of unseen substance, were thought to build slowly, gathering ordinary matter within their gravitational embrace over hundreds of millions of years. But Webb's images suggested something else. Galaxies forming and clustering with a speed that hinted at halos already mature, far earlier than the equations allowed. If dark matter truly shaped the cosmos, then its hand appeared swifter, more decisive, than the standard models had dared imagine. The tension grew, sharper when Webb's discoveries were compared with the frozen whisper of the cosmic microwave background. Planck's measurements had painted a precise portrait of the infant universe, smooth, uniform, and governed by predictable laws of expansion. Yet Webb's galaxies told a different tale, a cosmos that had structured itself more quickly, with luminous islands emerging sooner than expected. The two stories, one etched in radiation from 380,000 years after the Big Bang, the other captured in galaxies from 300 million years later, did not align. Between them lay a gap, a missing bridge in understanding, a rift that no adjustment of parameters could easily close. Astronomers began to wonder if the universe itself was less uniform than once assumed. Perhaps cosmic variance, the notion that different regions of the cosmos matured at different rates, was at play. If so, the universe was not the smooth and balanced expanse described by textbooks, but a landscape of uneven fertility, where some patches of space-time birthed galaxies in abundance, while others lagged in emptiness. Such an idea carried echoes of a deeper asymmetry, a hint that the cosmos might harbor hidden structures on scales far grander than any telescope could observe. Speculation turned also toward the stars themselves. The early generations, those first to burn in darkness, may have been stranger than imagined, titans far larger and shorter-lived than any seen today. Their deaths could have been swift and violent, flooding their galaxies with heavy elements in the blink of cosmic time, seeding black holes with mass that accelerated their growth. Perhaps Webb was not catching galaxies at odds with theory, but stars that rewrote the rules of stellar life altogether. And yet, even these speculations strained beneath the weight of the evidence. For some, the unease took a more radical shape. What if these luminous objects were not galaxies in the familiar sense at all? What if Webb had glimpsed structures that belonged to a category not yet named, entities that mimicked galaxies in light, but carried an essence beyond current physics? Were they pockets of exotic matter, bound in ways not yet conceived? Were they signatures of physics untested, laws unfolding differently in the crucible of cosmic dawn? Such questions lingered at the edge of science, fragile but impossible to dismiss. Through all of this, one truth pressed harder with each discovery. Webb had not simply looked deeper. It had looked beyond, to a realm where the patterns of physics grew faint, where the lines of certainty blurred. The telescope had become less an instrument of confirmation and more a key, unlocking doors to a reality that resisted comprehension. What it revealed was not only the infancy of galaxies, but the fragility of human understanding, the recognition that the laws once thought immovable might themselves be temporary scaffolds, waiting to be replaced. The weight of the mystery grew unbearable in its silence. Webb's golden mirrors reflected not only ancient starlight, but a new kind of question, one that reached past astronomy and into philosophy. Had humanity glimpsed the true universe, or only a shadow of something deeper, something waiting just beyond the horizon of known physics? The debate did not quiet with time. It only grew louder, more complex, and more unsettled. As teams across the globe sifted through the light web had gathered, they were confronted not with clarity, but with layers of paradox. Dark matter halos, once thought to be patient architects, seemed to have carved structures with impossible haste. If they had indeed formed so early, their nature might be more dynamic than previously believed, perhaps interacting in ways beyond the silent gravitational hand once ascribed to them. The invisible had become more mysterious, still leaving physicists to wonder whether dark matter's true character had been underestimated, or whether something else entirely was shaping the cosmic scaffolding. The clash with the cosmic microwave background cut even deeper. Planck's immaculate data, frozen in radiation, told of a universe governed by remarkable uniformity, smooth and featureless, save for the faintest ripples that seeded galaxies. Yet Webb revealed a sky already rich with luminous islands, some too massive, some too structured, too soon. It was as if two portraits of the universe, one from its infancy, one from its adolescence, had been painted by different hands. Reconciling them demanded more than adjustments to models. It required the unsettling possibility that the cosmos itself carried inconsistencies, or that the laws guiding its evolution shifted in ways still hidden. Some proposed that the answer lay in the very nature of space and time. If the fabric of the early universe behaved differently, expanding at uneven rates or governed by energies not yet understood, then the mismatch might not be an error but a revelation. The uniform stage set by the microwave background may have concealed hidden tensions, like currents beneath a calm sea, accelerating the growth of galaxies in ways imperceptible until Webb opened its golden eye. Attention turned toward the stars themselves. Perhaps the early universe had given birth to stellar giants far more extreme than theory imagined. Luminous behemoths hundreds of times the mass of the sun, burning through their fuel in mere millions of years. Their brief lives would have ended in cataclysm, scattering heavy elements, igniting new generations, and collapsing into seeds of black holes far larger than any formed today. Such stars would rewrite the tempo of the cosmos, explaining chemical richness and rapid galactic growth. Yet, despite the plausibility, no telescope had ever caught such giants in the act. They remained phantoms, inferred from necessity, their existence suggested only by the fingerprints they may have left behind. Still, even these bold conjectures could not fully silence the disquiet. For a growing number of scientists, the thought lingered that perhaps Webb was showing something that did not fit into existing categories at all. Objects glowing like galaxies but not bound by the rules of galaxies. Entities that defied description within the language of standard astrophysics. Some dared to whisper ideas that hovered on the border of science fiction, wondering if what was seen were not merely stars and gas, but signs of physics operating on principles still veiled to human thought. And in that silence between speculation and proof, the weight of the mystery grew heavier. The universe, revealed in Webb's deep gaze, did not simply stretch further than expected. It seemed to carry within it a depth of strangeness unanticipated by even the boldest theories. The telescope had not just sharpened vision, it had cracked the mirror of understanding, showing a cosmos that might be far less obedient to human laws than once believed. The question that hung in the air was no longer whether Webb had found anomalies, but whether it had glimpsed a reality that would force science to rewrite its most sacred principles at the furthest frontier of human knowledge. The universe begins to resist explanation. With each image that James Webb transmits, the scaffolding of established science trembles, as if the cosmos were whispering that its truths are deeper and stranger than the equations that once held them steady. General relativity, the grand theory of gravity, has guided astronomers for more than a century. Its predictions precise enough to steer spacecraft across billions of miles and to describe the dance of galaxies in the cosmic web. Yet in Webb's revelations, there are hints that relativity itself may be nearing its limits. Stretched thin across the immensity of the cosmos, gravity, so reliable within the solar system, may not behave in the same way across billions of light years, where its pull is entangled with forces beyond comprehension. Some turn their gaze toward dark energy, the unseen pressure that drives the universe apart. For decades, it has been treated as a constant, a quiet, unchanging property of space itself. But if dark energy shifts over time, waxing or waning in intensity, then the very speed of cosmic growth would fluctuate. Galaxies might coalesce faster in one era, slower in another, rewriting the rhythm of expansion and reshaping the timeline of creation. Webb's observations of early, mature structures may be the first tremors of this deeper truth, that what pushes the universe apart is not steady but restless, evolving alongside the cosmos it governs. Others wonder if the problem lies not with dark energy, but with the clock by which the universe is measured. Time, which seems so absolute in human lives, may not be so simple when traced across cosmic distances. Light, stretched and reddened by expansion, carries history in fragile streams, but perhaps its story is more complex than assumed. What if the way photons preserve the past is subtly distorted by unknown physics, bending the chronology of the cosmos itself? In such a case, Webb would not be showing an impossibly young galaxy, but a universe whose very timeline requires reimagining. Quantum mechanics, too, lurks at the edge of this puzzle. The smallest scales of existence, where particles blink in and out of being, are governed by rules alien to human intuition. If those rules ripple upward into the grand scale of galaxies, then cosmic history may be shaped by phenomena born from the quantum sea, fluctuations magnified into entire worlds, patterns etched into the structure of space-time itself. The first stars, the first black holes, the invisible skeleton of dark matter halos, all may bear the fingerprints of quantum processes reaching far beyond their expected domain. Stephen Hawking once warned that breakthroughs in cosmology are never gentle. Each discovery reshapes not just the universe, but humanity's place within it, stripping away comforting assumptions and replacing them with stranger, more profound realities. Webb's images carry that same disquiet. They are not just photographs of distant galaxies. They are mirrors reflecting the fragility of human understanding, pressing science toward questions that cannot be answered with old frameworks. The uneasy truth grows harder to ignore. The telescope may be brushing against the edges of a deeper law, a principle woven into reality that humanity has not yet glimpsed. The universe, in all its immensity, may not be bound to the categories of relativity, quantum mechanics, or cosmology as they stand. Something lies beyond, elusive and vast, waiting in the silence between galaxies. And with each golden fragment of light Webb gathers, the boundary between the known and the unknowable grows thinner, as though the cosmos is daring humanity to cross into a realm where physics itself must be rewritten. If relativity bends under the weight of Webb's revelations, then the question becomes, what comes after it? Some theorists turn to modified gravity, ideas that stretch Einstein's framework without fully breaking it. In these models, the force that binds planets to stars may not scale cleanly to the binding of galaxies within clusters or the weaving of the cosmic web. Perhaps gravity is stronger on the largest scales, pulling structures into order faster than expected, or weaker, allowing unseen forces to dominate the stage. Such ideas remain speculative, but Webb's images breathe new urgency into them. The sight of impossibly mature galaxies may not be an error of instruments, but the first tangible hint that gravity, the most familiar of forces, is stranger than anyone dared to believe. Dark energy, meanwhile, refuses to sit quietly at the edge of equations. If it evolves, if its influence grows or fades with time, then the entire story of cosmic history must be redrawn. A universe where dark energy waxes in strength would stretch apart faster in its later epochs. But in its earliest days, matter would have held greater sway. Galaxies could have condensed rapidly, stars born in furious waves, black holes seeded in storms of collapse. Webb's findings of rapid structure formation fit uncomfortably well with such a picture, one in which the cosmic engine that drives expansion has shifted gears across billions of years. Yet measuring such a change is no small task. Astronomers must disentangle subtle signals from the faintest galaxies at the edge of visibility, chasing patterns in light older than any star still burning today. Others reach toward the possibility that time itself may not flow evenly across the universe. In relativity, time dilates, slows, and bends under the influence of gravity and speed. But what if, on cosmological scales, time itself carries hidden asymmetries? Some cosmologists propose that the early universe may have unfolded under a rhythm different from what equations assume. In such a framework, light traveling across billions of years could encode distortions not yet recognized, compressing or stretching the apparent ages of galaxies. Webb may not be looking at paradoxes, but at truths refracted through a temporal lens humanity does not yet know how to read. Quantum theory casts yet another shadow across these mysteries. At the dawn of the universe, quantum fluctuations rippled across the fabric of space, microscopic in scale but amplified by inflation into vast imprints that shaped the distribution of galaxies. If quantum mechanics plays a deeper role than imagined, then what Webb observes might be evidence of structures seeded not by gravity alone, but by the restless energy of the quantum field. The first stars could have formed not as isolated beacons, but as bursts from quantum irregularities magnified into cosmic nurseries. In this view, the order seen in Webb's impossible spirals and luminous clusters is not a violation of physics, but the legacy of quantum, origins that still reverberate across time. Such speculation carries both wonder and unease. For every theory that offers a glimpse of resolution, new contradictions arise. Modified gravity strains against the precision of relativity's successes. Evolving dark energy challenges the elegance of the cosmological constant. Quantum cosmology, though compelling, reaches beyond what can be tested in earthly laboratories. Webb has not simply added new data to refine existing models. It has forced science into a realm where no single framework suffices, where the universe itself seems to resist confinement within familiar boundaries, and so, scientists find themselves at a threshold, staring into images that demand explanations, yet refusing to surrender their secrets easily. Each galaxy shining from the edge of time becomes more than a distant island of stars. It becomes a riddle, a challenge set by the cosmos itself. The sense grows that the telescope is not merely revealing the past, but pointing toward a deeper order, a set of laws as yet unspoken, waiting beyond the horizon of understanding. From the moment Webb's earliest deep fields arrived on Earth, the community of cosmologists set to work with sharpened pencils and restless nights, searching for explanations that could stitch these contradictions back into the familiar fabric of theory. The instinct was not to abandon the standard model of cosmology, but to bend it, to push its parameters to their extremes, and see if the universe could still be coaxed into alignment with the evidence. The first line of defense was star formation itself. Perhaps galaxies in the early cosmos were simply more efficient at turning primordial gas into stars than modern equations suggest. In this view, vast clouds of hydrogen and helium may have collapsed into stellar clusters with remarkable speed, lighting up the young universe in waves of brilliance. This efficiency would not break the rules of physics, but it would require that nature, in its infancy, favored a tempo far faster than the one witnessed in the galaxies of today. Attention then turned to the elusive population 3 stars, the hypothesized first generation of stars, never directly observed but long predicted. Unlike the stars of the modern cosmos, which are laced with elements forged in ancient supernova, these primordial giants would have been composed almost entirely of hydrogen and helium. Models suggest they could grow to hundreds of times the mass of the Sun, burning with ferocity and dying in violent supernova after only a few million years. Their brief lives would have flooded space with ultraviolet light and heavy elements, seeding galaxies with the ingredients needed for rapid maturity. If Webb was glimpsing the afterglow of such titanic ancestors, then the appearance of old, chemically enriched galaxies at impossible distances might be less paradoxical and more a reflection of how violently the early universe lived and died. Yet, even this scenario cannot fully account for the scale of the mystery. For scattered among the infant galaxies, Webb has found quasars, blazing beacons powered by black holes, already millions, sometimes billions, of solar masses across. According to standard models, such giants should require long epochs of steady accretion to grow, fed by a diet of collapsing stars and merging gas clouds. But Webb's images suggest they were already in place mere hundreds of millions of years after the Big Bang. To reconcile this, theorists propose direct collapse black holes, primordial seeds far larger than stellar remnants, born from the collapse of gargantuan gas clouds without ever passing through a phase of starhood. Such seeds could have accelerated the growth of galaxies, their gravity sculpting order from chaos, their radiation igniting cascades of star formation. The early universe, in this light, becomes a crucible where black holes may not just end stories, but begin them. Dark matter, too, is drawn into the puzzle. The invisible scaffolding upon which galaxies form is usually described as a slow architect, gradually pulling gas into filaments where stars ignite. But perhaps in the youth of the cosmos, this scaffolding was denser, its halos more efficient at binding matter together. If dark matter clustered faster, galaxies would have emerged earlier, their shapes taking form long before theory allows. Such an adjustment would not demand new physics outright, but a reweighing of the unseen, a recalibration of the invisible threads that bind the universe together. Yet the cost of this solution is steep. It risks unraveling the delicate concordance between dark matter models and the cosmic microwave background, whose patterns are explained so well by current assumptions. Another avenue lies further back, at the very dawn of everything. Perhaps the inflationary epoch, the fleeting moment after the Big Bang when the universe expanded faster than light, did more than simply stretch space smooth. If inflation seeded denser fluctuations in certain regions, then pockets of the cosmos could have condensed into galaxies with headlong speed, leapfrogging billions of years of expected evolution. This adjustment would allow for an uneven cosmic childhood, where some parts of the universe grew up faster than others. But such a possibility hints at something unsettling, that the universe may not be as uniform as once believed, that the very principle of cosmology, that all places, on average, look the same, might falter under Webb's gaze. Each of these theories holds a fragment of the truth, a patch on a tapestry that is fraying at the edges. Higher star formation efficiency explains some brightness. Population 3 stars have some chemical richness. Direct collapse black holes have some premature grandeur. Adjusted dark matter or inflationary models provide scaffolding for faster assembly. Yet no single idea binds them all. No single equation smooths the paradox into clarity. Instead, science finds itself surrounded by partial answers, like torchlight flickering on the walls of a cavern, illuminating details but never the whole chamber. Webb has forced cosmology into this liminal space, where the mainstream tools of adjustment strain against mysteries that may require something altogether new. If the early galaxies were brighter and more massive than expected, then the question naturally turned to the engines within them. Astronomers asked whether the rules of stellar birth and death might have been written differently in the infancy of the cosmos. Some models suggest that the cooling of primordial gas clouds may have been less restrained, allowing stars to ignite in bursts rather than gradual flickers. Without the metals that now regulate star formation, these clouds could collapse more readily, birthing clusters of stars with extraordinary luminosity. This scenario does not merely shift the timeline. It reimagines the character of the first stars as architects of acceleration, engines that drove cosmic structures forward with reckless speed to test these possibilities. Researchers turn to Webb's spectroscopic data, the fingerprints of light that betray the chemical composition of distant galaxies. The evidence has been sobering. Within systems thought to exist only a few 100 million years after the Big Bang, Webb has detected heavy elements, oxygen, carbon, even traces of iron. These elements cannot form without multiple generations of stars burning and dying. Yet their presence suggests that entire stellar life cycles occurred in the blink of cosmic time. It is as though history itself has been compressed. Epochs folded together until what should have been separated by eons is instead stacked within mere moments. The mainstream view has responded by positing hyperaccelerated stellar cycles, where massive stars flare to life, die in supernova, and recycle their material with extraordinary efficiency. But here too, the theory strains against probability, demanding that nature played its opening act in fast forward. The idea of early supermassive black holes carries its own unsettling weight. In standard cosmology, black holes are endpoints, the final cinders of massive stars, slowly fattened by steady accretion over billions of years. Yet Webb has shown them already ablaze in quasars, bathing their surroundings in light powerful enough to be seen across the breadth of the universe. Mainstream astrophysics now entertains the idea that these giants began as direct collapse objects, black holes born whole, with masses perhaps 10,000 times that of the Sun from the outset. If true, the universe was not merely creating stars and galaxies in its youth, it was also forging monsters. The difficulty lies in reconciling this with the delicate cosmic background radiation measured by Planck, which offers no hint of such dramatic anomalies. Here, the tension grows sharper. For every patch applied to explain, Webb's galaxies risks tearing at the fabric woven by earlier data. Dark matter remains the most tempting lever for adjustment. Its nature is unknown, but its gravitational influence shapes the cosmos. If its behavior in the young universe diverged slightly from assumptions, clustering more rapidly, collapsing into denser halos, then galaxies would have assembled sooner. This theory maintains the core framework of cosmology while granting enough flexibility to account for Webb's images. But the cost is precision. The concordance model, the elegant balance of dark matter, dark energy, and baryonic matter that explains so much, begins to wobble. Each tweak threatens a cascade of contradictions elsewhere. In gravitational lensing data, in the distribution of galaxies, in the ripples of the cosmic microwave background, like pulling on a loose thread, it may unravel more than it mends. Some astronomers look even deeper, to inflation, the primordial expansion that set the stage for everything. If inflation generated more pronounced fluctuations in certain regions, galaxies could have condensed rapidly there, while others lagged behind. This would explain Webb's overabundance of massive galaxies as pockets of exceptional density. Yet this solution whispers of something profoundly unsettling, that the universe is not as smooth and uniform as cosmology has long assumed. If the early cosmos was uneven, then the laws that govern its evolution may not apply universally. This strikes at the very foundation of the cosmological principle, the assumption that our patch of sky is not privileged, that the whole universe plays by the same rules. The mainstream theories each preserve the spirit of known physics. None requires abandoning Einstein's relativity or rewriting quantum mechanics. They extend, stretch, and reframe, but do not overthrow. Yet the paradox remains unresolved, lingering like an echo in the data. The galaxies Webb has revealed do not simply test the limits of our models. They expose the fragility of the models themselves. Science has long thrived on such moments, where the known begins to tremble under the weight of the observed. In the glow of these impossible galaxies, one sees not the end of cosmology, but its renewal. A reminder that even the most trusted frameworks are provisional, waiting to be reshaped by the next great instrument that dares to look deeper. Some mysteries invite refinement, others demand imagination. As the early results from Webb unsettled the pillars of cosmology, a quieter chorus began to speak, voices willing to step outside the boundaries of mainstream theory, to entertain visions that brush against the edge of the conceivable. It is here, at the frontier between physics and philosophy, that speculation stretches its wings. The impossible galaxies did not merely hint at unknown details of star formation or dark matter clustering. They whispered of deeper cracks, fractures that may run all the way to the foundation of reality itself. For some, the solution lies not at the dawn of galaxies, but before the beginning of the universe itself. Alternative cosmologies suggest that the Big Bang was not the ultimate origin, but a transition, a bounce, perhaps from a prior universe collapsing into itself and then reborn. In this view, the cosmos has no singular birth, but a heartbeat pulsing across eons in cycles of expansion and contraction. If Webb's galaxies seem impossibly mature, it may be because their seeds were sown in an earlier cycle, relics of a pre-Big Bang past carried forward into the present epoch. Such an idea echoes through ancient philosophies as much as it does through modern physics. Creation not as a singular miracle, but as a rhythm without end. Others push the limits of relativity itself. Variable speed of light theories propose that, in the early universe, light may not have moved with the same unwavering constancy it does today. If photons once traversed the cosmos more swiftly, then distances shrink, timelines compress, and galaxies that appear impossibly ancient could, in fact, be less paradoxical. This notion undermines one of the most sacred constants of physics. Yet constants are only as unchanging as the reality they describe. The very idea that light speed could vary feels like heresy. But heresy has, more than once, become tomorrow's orthodoxy. In the most unsettling corners of speculation lies the simulation hypothesis. What Webb may have uncovered is not an ancient galaxy at all, but a flaw in the rendering of reality. If the cosmos is a coded construct, then its edges may not align perfectly. Like glitches in a digital landscape, inconsistencies appear only when resolution is pushed to extremes. Webb, with its golden mirrors and infrared gaze, is precisely such a probe, staring so deeply into the code of existence that seams begin to show. The galaxies that defy physics could be artifacts of architecture not written by nature, but by something else, a reminder that perhaps the universe itself is an illusion, projected upon a screen we cannot perceive. Others turn to the multiverse, a vision of infinite realities layered like waves upon an endless sea. In such a scenario, the galaxies Webb observes may not belong fully to ours at all. They could be echoes of structures from a neighboring cosmos, bleeding across the invisible boundaries that separate universes. Gravitational fields, quantum entanglement, or topological folds in space-time might allow a sliver of another reality to leak into view. If true, Webb has not only shown us the early universe, it has revealed the existence of other universes, hidden but close, pressing against the edges of our own. Still others imagine that gravity itself is not fundamental, but emergent, a property arising from the deeper fabric of quantum information. In this framework, space-time may not be continuous at all, but woven from discrete threads of data, vibrating at scales too small to measure. The anomalies Webb reveals could be the fingerprints of this deeper lattice, the way a magnifying lens exposes the weave of a canvas beneath a painting. What appears as premature galaxies might be patterns imposed by the geometry of quantum space-time itself, not errors, but signatures of a reality more profound than general relativity allows. Each of these speculative theories carries with it both daring and danger. They defy the comfort of established science, demanding leaps into unknown waters where evidence is scarce and mathematics not yet settled. And yet, history shows that when observation breaks the spine of theory, the next chapter often emerges from ideas once dismissed as fringe. Webb has not proven these visions true, but it has breathed life into them, forcing the scientific imagination to widen its scope. The unsettling possibility remains that these impossible galaxies are not merely puzzles to solve, but cracks in the facade of physics itself, hints that our universe, as described by current science, is only a shadow of a deeper, stranger truth. The tension between wonder and skepticism is the heartbeat of this frontier. Scientists approach Webb's anomalies with caution, yet even the most conservative minds cannot ignore the persistent oddities in the data. Each galaxy, each luminous cluster appearing far too mature for its cosmic age, challenges the assumptions embedded in decades of theoretical frameworks. The speculative scenarios are not frivolous flights of imagination. They are intellectual scaffolding, provisional maps guiding inquiry into territories where mainstream theory hesitates to tread, to entertain the possibility of pre-Big Bang remnants. Variable light speeds or multiversal leakage is not to abandon reason, but to acknowledge that the universe may be more nuanced, layered, and subtle than any single model can capture. Consider the philosophical weight of these possibilities. If the cosmos is cyclic, and our galaxies carry echoes from prior epochs, then the notion of a beginning, a singular, absolute origin, dissolves into a rhythm of perpetual creation and collapse. Time becomes less a linear river and more a symphony of pulses, each cycle folding into the next, leaving traces that Webb can now glimpse. The familiar language of cause and effect strains under such interpretations. The age of a galaxy no longer denotes a fixed history, but a tapestry woven from multiple temporal threads. In this vision, the universe is not merely vast, but timeless, an enduring stage upon which stars and black holes play fleeting roles in a drama that transcends singular moments. If light itself once flowed differently, as variable speed theories suggest, then the cosmos is even stranger than our instruments can directly measure. The distances inferred from redshift, the stretching of light by cosmic expansion, may be deceptive, creating the illusion that galaxies are older and larger than they truly are. Webb may be observing a universe whose history is encoded in a medium that bends under conditions we do not yet comprehend, where photons are not mere messengers, but participants in a cosmic story whose rules change with epoch. This reframes the act of observation itself, reminding us that what we see is not just a passive reflection of reality, but an interpretation filtered through the laws of physics, laws that may themselves have evolved. The multiverse hypothesis, in its quiet audacity, forces an even more radical reconsideration. If fragments of other universes can bleed into ours, then the cosmos is no longer self-contained. Structures that seem impossible under our laws may be wholly natural in a broader landscape of realities. Webb's gaze, focused like a scalpel on the fabric of space-time, might have inadvertently captured these interlopers, luminous witnesses from neighboring worlds. Here, the distinction between observation and intrusion blurs. Science encounters not just the unknown, but the unknowable, and the act of measurement becomes a dialogue with realms beyond our universe. Quantum and emergent theories offer yet another lens. If space-time is woven from discrete quanta of information, then the patterns Webb observes may be the visible traces of this deeper architecture. Galaxies, black holes, and dark matter halos could be emergent phenomena, manifestations of principles more fundamental than geometry or gravity. What appears as anomalous brightness or structure may be a natural outcome of rules operating beneath the continuum. A cosmos whose very scaffolding is still hidden from direct perception. In this light, the telescope does more than reveal distant stars. It illuminates the latticework of reality itself, exposing textures and vibrations of a universe yet to be fully understood. And so, each image Webb returns becomes a meditation on the fragility of knowledge. Mainstream models provide guidance, speculative theories provide vision, but neither can yet claim final authority. The telescope has opened a crack, a slit through which the cosmos whispers of truths that defy categorization. The mystery is no longer confined to the edges of astrophysics. It seeps into philosophy, into the human confrontation with limits of comprehension. It is a reminder that understanding is provisional, that the universe may be stranger, older, and more profound than the mathematics we trust can ever fully capture. In this luminous darkness, science becomes an act of wonder as much as inquiry, and the impossible galaxies that Webb reveals are monuments not merely to cosmic evolution, but to the audacity of human curiosity itself. Across the globe, observatories hum with quiet urgency, their instruments trained on the faintest glimmers of the distant universe. From the frozen peaks of Mauna Kea, the twin eyes of the Keck Observatory pierce the night sky, their adaptive optics compensating for the restless turbulence of Earth's atmosphere. In the Atacama Desert, the Very Large Telescope aligns its mirrors with meticulous precision, each adjustment a silent prayer for clarity. And on the horizon looms the extremely large telescope, whose 39-meter primary mirror promises to bring even the faintest, most impossible galaxies into focus. Together with Webb, these ground-based giants form a network of vigilance, a collaborative gaze that spans continents and time zones, chasing answers in the faint infrared light that has traveled billions of years to reach them. Supercomputers work in parallel, their processors churning simulations that attempt to recreate the cosmos. Virtual universes unfold across arrays of silicon, each galaxy, star cluster, and black hole governed by the laws known to physics. Yet even with these extraordinary machines, the galaxies Webb observes refuse to be mimicked. They emerge too early, too massive, too structured anomalies that stretch every assumption embedded in the code. Researchers tweak parameters, pushing star formation rates higher, compressing dark matter halos, experimenting with early black hole growth, but the simulations remain stubbornly incomplete. The models provide guidance, frameworks within which to interpret the observations, yet the cosmos seems to challenge even the most sophisticated theoretical scaffolding, teasing the limits of human understanding. Meanwhile, the cadence of discovery is set by the data release cycles of Webb itself. Each new deep field is met with collective breath-holding. Astronomers, students, theorists, and the curious alike peer into the universe's infancy, scrutinizing every photon for anomalies, patterns, and clues. The anticipation is tangible, a global heartbeat that pulses with every dataset. Papers are drafted, conferences convened, debates flare and subside, a rhythm that mirrors the very evolution of the galaxies under study. Collaboration and competition intermingle. Researchers push each other toward rigor, toward insight, yet also jockey subtly for precedence, aware that in this moment, every insight carries the weight of history. Amidst this intense human endeavor, there is an acute awareness that history is unfolding in real time. The universe is revealing itself not in centuries or millennia, but in the cadence of months and years. What Webb captures today will influence textbooks tomorrow, reshape theoretical frameworks, and redefine what humanity believes possible. Observers feel themselves as witnesses at the threshold of understanding, participants in a cosmic drama whose script is written in the glow of ancient starlight. Each confirmed anomaly, each spectroscopic fingerprint, each simulation that falls short is a reminder that science is alive, evolving alongside the cosmos it seeks to describe, that our grasp on reality is tentative, and that the universe, in its vast, patient indifference, continues to challenge every certainty here. At the intersection of technology, intellect, and wonder, the quest continues to observe, to simulate, to understand, and perhaps to reconcile the impossible with the known. Webb's revelations are no longer isolated flashes. They have become a clarion call, urging humanity to stretch its gaze further, refine its tools, and deepen its imagination. And while the answers remain elusive, the pursuit itself transforms the scientific landscape, forging new methods, new collaborations, and a renewed sense that the universe is not a static canvas, but a living, dynamic narrative in which we are privileged to participate. Amid the hum of instruments and the glow of computer screens, a quieter reflection emerges, a human response to the immensity Webb has revealed. Astronomers, once accustomed to thinking of the universe as a slow, predictable progression, now confront a cosmos that seems capricious, that matures with a speed and complexity beyond expectation. The emotional weight of this realization is subtle but profound. To see galaxies fully formed when the universe was scarcely 300 million years old is to glimpse the audacity of nature itself. Each observation is not merely data. It is a reminder that the universe is a place of surprises, that the cosmos does not yield its secrets gently, and that the human mind is both challenged and elevated by the act of comprehension. The philosophical implications are equally vast. If the universe is capable of producing structures so mature so early, then the narrative of cosmic evolution, a story long told in textbooks and lectures, must be reconsidered. Our models, our constants, our carefully measured parameters may describe only part of a far larger, more intricate reality. The very notion of causality, of chronological inevitability, is subtly unsettled. Scientists, philosophers, and even poets find themselves pondering questions once reserved for speculation. What does it mean for a galaxy to exist before time itself seems to have matured? Is the universe more like a living organism, capable of accelerated growth and unforeseen creativity, rather than a clockwork mechanism unfolding in strict accordance with physical law? There is also a human narrative woven through the science. Webb itself is a triumph of imagination, engineering, and international cooperation, a testament to humanity's capacity to build instruments capable of reaching across billions of light years. The telescope's golden mirrors are not just tools, but symbols of curiosity, of ambition, of a collective yearning to understand our origins. Each team analyzing the data, each theorist proposing models, each observer marveling at the images participates in a continuum of exploration that stretches from Galileo to Hubble, from Hawking to the present. In this sense, the story is not solely about distant galaxies, but about us, the species capable of conceiving of, reaching for, and interpreting the faintest whispers of light from the dawn of time at the same time. The discoveries evoke a kind of existential humility. The cosmos, in its scale and speed, renders human lifespans almost ephemeral, a fleeting beat in the symphony of billions of years. Yet within this vastness, there is resonance, the pursuit of understanding, the patience required to decode the ancient light, and the awe elicited by structures forming when time itself was young, remind us that curiosity and reflection are our most enduring legacies. Through Webb, we confront not only the universe's complexity, but also the depths of our own desire to find meaning in the vast and mysterious expanse that surrounds us. Finally, there is the lingering sense of wonder that must accompany any true engagement with these revelations. Science, at its best, is not merely a collection of facts, but a journey of the imagination tempered by observation. Webb has illuminated questions that were invisible until now, prompting both careful analysis and quiet contemplation. As each impossible galaxy appears in the infrared glow of its deep field, humanity is reminded of the fragility and brilliance of knowledge, of the courage it takes to confront the unknown, and of the profound beauty of a universe that continues to surprise, to challenge, and to inspire. In the end, the telescope does more than reveal distant light. It reflects back to us the luminous curiosity that defines our species, and the infinite possibilities that remain, waiting just beyond the edge of understanding. In the faint glow of Webb's deepest fields, there is a quiet lesson in humility. Every photon that reaches the telescope's golden mirrors carries the imprint of a universe far older than Earth, older than life itself, yet interpretable by minds that are, in cosmic terms, almost infinite. The astonishment of discovery is tempered by the awareness of limitation, the realization that no matter how advanced our instruments, how elegant our equations, the universe will always contain corners beyond reach. layers of complexity that defy immediate comprehension. Einstein once remarked, "The most incomprehensible thing about the universe is that it is comprehensible." Webb's revelations exemplify this paradox. The cosmos is at once graspable and elusive, a riddle that teases the edges of understanding while permitting glimpses into its profound order. There is a deep human need for mystery, a drive to seek the boundaries of knowledge, not merely for utility, but for the sheer nourishment of curiosity, to peer into the universe's infancy, to see galaxies already mature when the cosmos was young, is to confront the tension between expectation and revelation. It is a reminder that the pursuit of science is inseparable from wonder, that each discovery carries both information and poetry, that the act of observation is itself a bridge between human consciousness and the vast, indifferent expanse of space. Webb is more than a telescope. It is an extension of imagination, a tool that transforms speculation into data, and data into narrative, revealing not just the cosmos, but the yearning embedded within those who seek it. In a way, Webb is a mirror. Its gaze stretches backward through billions of years, yet in doing so, it reflects our own desire to understand origin and meaning. The questions it raises about the age of galaxies, the speed of cosmic evolution, the behavior of matter and light, are as much about the universe as they are about ourselves. Each anomaly, each unexpected structure, challenges preconceptions and invites reconsideration, suggesting that what we call physics may be only a chapter in a far grander story, that our equations are provisional sketches of a cosmos whose rules extend beyond present comprehension. Perhaps, then, the universe is not broken, nor defiant, nor incomprehensible in its totality. Perhaps it is an invitation to look again, to refine perception, to see with new eyes. In the light of ancient galaxies, in the whispers of quasars blazing from the dawn of time, humanity glimpses not only what has been, but what may yet be understood. Webb has shown us that the cosmos is both stranger and more intimate than we imagined, a vast stage for the human pursuit of knowledge, a luminous reminder that the act of seeking, the curiosity, the reflection, the audacity to question, is itself a bridge to the infinite. And in this pursuit, we find meaning, not merely in the answers we uncover, but in the courage to ask, to wonder, and to see anew the human impulse to explore, to push beyond familiar horizons, finds its reflection in every observation Webb returns. Each image of a distant galaxy, each spectral line that betrays chemical composition or star formation rates, is a testament to both cosmic history and human curiosity. In these faint lights, we see a dialogue between observer and universe, a conversation conducted across billions of years, across the void, across the limits of comprehension. The act of understanding becomes simultaneously an act of humility, for the universe does not yield itself easily. It offers hints, patterns, and anomalies, but no complete picture. In recognizing this, humanity confronts the delicate tension between knowledge and mystery, the delicate balance that defines both science and philosophy. These reflections extend beyond the scientific community. For the lay observer, for anyone gazing upon Webb's images, there is a profound sense of scale and temporality. To see galaxies fully formed in what should have been the cosmic dawn is to feel the weight of time differently, to appreciate that existence is layered, expansive, and often counterintuitive. It forces an emotional reckoning. Our lives, our civilizations, our fleeting achievements, are measured in decades, centuries, perhaps millennia, but the universe measures in billions of years. Yet within this immensity, our capacity to observe, to theorize, to dream is a beacon. It affirms that intelligence, curiosity, and imagination are as much forces of the cosmos as gravity or light. Philosophically, Webb's discoveries challenged the assumption that human understanding is ever complete. The telescope does not merely illuminate. It provokes. It exposes gaps in theory, anomalies in expectation, and patterns that strain the elegance of established models. Each anomaly carries not just a scientific puzzle, but a reminder of our provisional place in the cosmos. That certainty is always tentative, that the known is only a fragment of what exists. The universe, in its silent vastness, encourages not resignation, but wonder, a patient, persistent call to keep seeking, to refine perception, and to remain open to ideas that may currently seem impossible. Finally, Webb's revelations inspire a contemplation of continuity and connection. The light it gathers has traveled across space and time to reach a fragile human instrument. Yet it speaks to universal processes that transcend species, planets, and epochs. The galaxies we observe were forged by stars, gravity, and quantum fluctuations in a universe indifferent to observation, yet capable of conveying meaning through the act of seeing. In this interplay, humans become participants in a cosmic narrative, interpreters of signals older than Earth, and witnesses to processes that shaped all matter, all life, all that is familiar. In such reflection, science and philosophy converge. To understand the universe is, in part, to understand ourselves, our curiosity, our resilience, and our enduring desire to glimpse the infinite. The invitation is clear: to look, to question, and to see not merely with instruments, but with imagination attuned to the subtlety and grandeur of a cosmos that continues to surprise, challenge, and inspire. Perhaps, as Webb demonstrates, the universe is not a closed book awaiting final answers, but an open manuscript written in light, waiting for those willing to read it with eyes unclouded by presumption and hearts open to wonder. The story of James Webb's revelations is not only about galaxies and physics, it is also about the human condition. In every golden mirror polished to perfection, in every calibration sequence running silently in orbit, there is a reflection of the species that built it, a fragile creature on a small planet, conscious of its limitations, yet determined to look beyond them. Humanity, for all its flaws and imperfections, has always been drawn to the horizon, to seize untraveled mountains, unclimbed skies uncharted. Webb represents a new horizon, not on Earth, but in the fabric of time itself. It extends the reach of human vision back to the very dawn of structure, when the first stars ignited in the silence after the Big Bang. To build such an instrument is to declare that ignorance is not an end state but an invitation, that the unknown is not a void to fear but a frontier to embrace. Yet, when Webb's images arrived, what they showed was not a comforting confirmation but a profound disturbance. The galaxies, too bright, too massive, too early, seemed to whisper of errors in human understanding. For scientists, this was not a moment of defeat, but of awakening. Theories, carefully woven over decades, began to fray. The standard model of cosmology, the great narrative of expansion, cooling, and gradual assembly, suddenly bore cracks that could not be ignored. But here lies the essence of science. Its power is not in having the final word, but in welcoming revision. The very act of finding contradiction is evidence of progress. Webb's defiance of expectation did not close doors, it opened them wider. For philosophers, this moment resonates deeply. Human knowledge is always provisional, always situated within the limits of perception and imagination. To believe otherwise is hubris. What Webb revealed was not merely ancient galaxies. It revealed the humility required of intelligence in an evolving universe. The light that reached Webb's mirrors carried histories beyond comprehension, histories untouched by human existence. It reminded humanity that the universe is not obliged to make sense within the frameworks already devised. Reality exceeds theory. The cosmos is under no contract to remain tidy, comprehensible, or convenient. And yet, the miracle is that it can be comprehended at all, at least in fragments. Einstein once observed that the most incomprehensible thing about the universe is that it is comprehensible. His words echo here. Against the infinite silence of space, against the overwhelming immensity of billions of galaxies, human minds can recognize laws, patterns, and symmetries. Mathematics becomes a bridge across eternity. Physics transforms scattered photons into a narrative of creation. But comprehension is never complete. It is a scaffold rising endlessly, each rung supported by those before, but never reaching the summit. Webb's anomalies are another rung, a sign that the structure must grow taller, stronger, perhaps even differently shaped. This raises a deeper reflection on the nature of truth itself. Is truth a fixed entity, waiting to be uncovered, like an artifact buried in sand? Or is it more like a horizon, receding as one approaches, always leading further, never final? Webb suggests the latter. The universe, in all its depth, does not seem to allow final answers. Instead, it offers layers of revelation, each deeper than the last, each raising new questions even as it resolves old ones. In this sense, science becomes not a march toward closure, but a dance with mystery, a rhythm of discovery and doubt, of order and surprise. The psychological dimension of Webb's findings is equally profound. To confront anomalies is to confront uncertainty, and uncertainty breeds both fear and wonder. For centuries, humanity has sought security in explanation, in the sense that the world is knowable and, therefore, controllable. But Webb reminds us that control is an illusion. The universe is not a machine built for human comfort. It is an unfolding reality whose scope far exceeds imagination. This realization can feel disorienting, even existential. If galaxies exist earlier than physics permits, what else lies hidden in the darkness, beyond instruments and theories? If the very laws thought to govern reality prove incomplete, then reality itself becomes stranger, less predictable, more fragile. Yet it is in fragility that beauty often resides. Just as a delicate flower is more moving for its vulnerability, so too is human knowledge more meaningful because it is never absolute. The cracks revealed by Webb do not diminish the grandeur of physics. They elevate it. They testify that reality is inexhaustible, that there is always more to learn, more to imagine, more to seek. Mystery is not a flaw in the cosmos. It is its essence. Without mystery, curiosity would die, and with it, the very drive that built Webb in the first place. The cultural implications ripple outward. Webb's discoveries unfold in a time when humanity is increasingly fractured, divided by nations, ideologies, and crises of survival. Yet here is a reminder of unity. The galaxies Webb observes are not American or European, not Eastern or Western. They belong to no one and everyone. The photons striking its sensors began their journey before Earth itself solidified, long before any borders were drawn or languages spoken. To study them is to participate in a collective inheritance, a heritage of existence shared across all humanity. This is science, not as conquest, but as communion. It is striking, then, how the universe functions as a mirror. What Webb reveals about galaxies also reveals something about those who look at them. Just as the galaxies formed sooner than expected, so too has human civilization advanced faster than once imagined. Only a few centuries ago, the idea of peering into the first billion years of the universe would have been fantasy. Now it is reality. In this acceleration, there is both triumph and peril. Humanity's capacity to build telescopes, rockets, and computers grows exponentially, but so too do the risks of hubris, distraction, and short-sightedness. Webb's message may be as much ethical as scientific: to see further. One must also think deeper, live more wisely, and act with humility before the scale of creation at a deeper philosophical level. Webb invites reconsideration of the concept of time itself. The galaxies it reveals are not in the past in the ordinary sense, for they still exist, perhaps now transformed beyond recognition. What Webb sees are echoes, records written in light, carrying news billions of years old. Time, in this view, is not a simple flow, but a layered tapestry. The present contains the past within itself, encoded in radiation, gravity, and the very structure of space. To observe the universe is to engage in a form of time travel, to witness not only what was, but also the continuing resonance of what is. This perspective alters human self-perception. Life, brief as it is, participates in a cosmos where past and present intermingle across unimaginable scales. This realization can be both humbling and liberating. If humanity's place is so small, why should its struggles matter? Yet if the universe is so vast, why should existence be meaningless? Webb suggests another way of seeing. Meaning does not require dominance. It requires participation. To be a participant in the cosmic story, to be a being capable of wonder, is significance enough. The galaxies do not know they are being observed. The photons do not intend to tell a story. It is human consciousness that reads meaning in them, and in doing so, adds a new chapter to the universe's unfolding. Consciousness itself becomes a cosmic phenomenon, a way the universe reflects on itself. For theologians and metaphysicians, Webb's discoveries may stir echoes of older questions. If reality exceeds current theories, does it also exceed all possible theories? Is the cosmos finite in explanation, or infinite in its refusal to be contained? Does the presence of order alongside mystery suggest an underlying intelligence, or simply a natural complexity beyond comprehension? Science cannot answer these questions definitively, but it can illuminate their contours, offering new data that deepens rather than diminishes wonder. Even within the scientific community, there is recognition that Webb's revelations mark not an end, but a beginning. Every anomaly becomes a seed for new inquiry, new instruments, new models. Just as Galileo's telescope redefined astronomy, just as Hubble's observations redefined cosmology, so too will Webb's discoveries redefine the future. Perhaps new laws will be written, or perhaps existing ones will be reshaped. Perhaps unexpected connections will emerge, uniting quantum mechanics and relativity, particle physics and cosmology. In this possibility lies the greatest philosophical lesson of all, that knowledge is not static, but evolutionary, and that every generation participates in its unfolding. One cannot ignore the emotional dimension that underlies all of this. To see Webb's images is to feel awe, but also a subtle melancholy. The galaxies it reveals are gone as they once were. The light we see is a memory, not a presence. In this sense, Webb's vision is akin to reading an ancient diary, its author long vanished. It reminds humanity of mortality, of the fleeting nature of all things, even stars and galaxies. Yet it also affirms continuity. Though stars die, galaxies collide, and civilizations rise and fall, the story continues. The universe, indifferent yet magnificent, goes on writing itself in light, waiting for those willing to read. And so, the chapter closes on reflection. Perhaps the universe is not broken. Perhaps it is not defying physics, but defying the limits of imagination. The galaxy's web has revealed are not errors, but invitations. Signs that the story is larger, richer, and more surprising than once believed. To accept this is to embrace wonder as a way of being. To recognize that existence is not a problem to solve, but a mystery to live within. Webb, in this light, is more than a telescope. It is a mirror, not of galaxies alone, but of humanity's endless desire to see, to know, and to find meaning in the silent depths of the cosmos.